15F deals with parallelism. In other words, we're trying to see if two vectors are parallel. And if two vectors are parallel, then that means that one is a scalar multiple of the other. In math, we say that vector A is parallel to vector B if there exists a k, remember k is a number, such that k times vector A is equal to vector B. Geometrically speaking, if you look at this graph, I have two vectors. I will label the blue line vector B, and I will label the red line vector A. And if you look at it, and if you look at it and take a look over here, I'm just moving A over here, and this is still A, and move it on top. Notice that vector B is equal to 2 times vector A. So here I could say that vector A is parallel to vector B because there exists some number, and that number being 2, such that vector B is equal to the product of some value times vector A. Moving on, just one page, here are some more examples. If vector A is equal to 2, 5, and vector B is equal to negative 20 over 50, and vector C is equal to 6 over 15, then the first thing we want to know is vector A parallel to B? And the second thing we want to know if vector A is parallel to C. Well, according to my equation, vector A is parallel to vector B if there exists some number, 2, 12, 15, a half, or 32, such that Ka equals to B. So we start off by simple substitution. K is what we're looking for, and A is 2, 5. And can I make that equal negative 20 over 50? Well, using some simple steps of math, I'm just going to scroll down a little bit to get me some room here. I could use the distributive property, and that gives me the 2k, 5k will equal to negative 20, 50. Now, remember, equal vectors means that they go in the same direction and they have the same length. In component form, that means that their x values are equal and their y values are equal. If I solve for k using basic algebra, divide by 2, and over here I divide by 5 and I divide by 5. I get k equals to negative 4, and right here I get k equals to 4. Notice I have two different values for k, 4 and negative 4. Since it's not the same value, we say that vector A is not parallel to vector B. Well, let's try the other vector. Is vector A parallel to vector C? Well, according to the definition, vector A is parallel to vector C if there exists some value k, right here, some number k, such that that number times A will equal to C. Using substitution, again, vector A is 2, 5, and then vector C is 6, 15. Using the distributive property, I end up with vector 2k, 5k is equal to vector 6, 15. Again, if two vectors are equal, then the x component of one vector will equal the x component of the other, and the y component of one vector will equal to the y component of the other. Using basic algebra again, I divide this by 2, divide this by 2, divide this by 5, and divide this by 5. I come up with k equals to 3, and k equals to 3. Notice, I have the same k. Therefore, I could say 3 times vector A equals to vector C. Or, I forgot the little vector symbol, or vector A is parallel to vector C. Oops, wrong one.